All right, today we're going to pull back the curtain on the world of construction. We're diving deep to uncover the secret life of a small, but honestly, an incredibly powerful component that literally holds our modern world together.
You see these incredible structures every single day. Towering skyscrapers, giant stadiums, you name it. They're these amazing monuments to human engineering that we just kind of walk past without giving them a second thought.
But have you ever really stopped to think about what's going on deep inside all that concrete and steel? What are the invisible secrets, the unsung heroes, making sure these giants don't come tumbling down?
Well, that's what brings us here. We're going to zoom way in, from the massive scale of a skyscraper down to a tiny piece that acts like a crucial handshake between all the giant parts. And this is it. Meet our hero for this explainer, the embedded steel plate, or what everyone in the industry just calls an embed. I know it might not look like much, but this little piece of steel is the critical connection, that handshake, between the building's concrete skeleton and pretty much everything else.
So what is this thing really? Well, an embed is basically a steel plate with these things that kind of look like mushrooms welded to the back. They're called headed studs. The whole thing gets placed right into the wet concrete. And once that concrete hardens, those studs lock it in, making it a permanent, rock-solid anchor point inside the structure.
And what does it connect? The short answer? Pretty much everything. We're talking the main steel beams of the building's frame, the glass walls on the outside, the rails for the elevators, steel stairs, even huge mechanical and electrical gear. This one little component is absolutely everywhere, doing its vital job completely out of sight.
But here's the thing. An embed's journey doesn't actually start on that loud, chaotic construction site. Nope. It begins way before that, in the quiet, super precise world of engineering. It's all forged in the blueprint.
And this right here, this shows you the core challenge perfectly. You've got the clean, orderly plan versus the messy, crowded reality of the job site. For engineers, the single biggest headache is trying to design around that inevitable chaos, especially that dense jungle of steel reinforcing bars or rebar.
So how do they do it? They get clever. They literally design for conflict before it even happens. One strategy is to make the steel plates up to 6 inches bigger than they need to be. That extra room gives the workers on site wiggle room to shift the embed around if it bumps into a piece of rebar. They even have a rule that there has to be at least an inch of space around it, just to make sure the concrete can flow in and grab hold of everything properly.
And the level of precision needed is just wild. Take this for example. When you're welding this plate, the weld can't be too big. The rules say you have to leave at least 1/16 of an inch of the steel edge totally untouched. That's thinner than a dime. If you go even a tiny bit over, you risk literally melting the corner away, which could compromise the entire connection. We're talking about a tiny margin of error on something that's supposed to last for a century. The stakes are just incredibly high.
Okay, so our embed has been designed and built with insane precision. Now it has to get ready to survive in the real world for a very long time. It needs a suit of armor.
To stop it from rusting away and make sure it can last for decades with zero maintenance, our embed gets a bath in a giant tub of molten zinc. This whole process is called hot dip galvanizing, and it creates this incredibly tough bond that acts like a shield against corrosion.
Now, here's where things get interesting, and frankly, a little confusing for folks on the job site. When these parts come out of the zinc bath, they can look totally different. Some are bright and shiny, while others are this dull, matte gray.
So take a look at these two. Which one do you think does a better job protecting against rust? The shiny one that looks all new, or the dull one?
Yeah, it's a trick question. The answer is, they're both exactly the same. The appearance of a galvanized coating has absolutely nothing to do with how well it fights corrosion. The only thing that actually matters is the thickness of the zinc, not how shiny it looks.
So, why do they look different then? It all just comes down to chemistry. It's about tiny amounts of silicon and phosphorus in the steel itself, or how fast the part cools down after its hot dip. Even stress in the steel can change the finish. But the key takeaway is, the look doesn't matter. The protection is the same.
All right, our embed is designed, it's fabricated, it's got its coat of armor. Now it faces its biggest challenge yet. It's time for the on-site gauntlet. Once it arrives on site, the embed gets dropped into what can only be described as a dense forest of steel rebar. I mean, look at that. Everything is fighting for the exact same space, and our perfectly made embed has to find its one precise home in all of that chaos. And things almost never go perfectly according to plan. It's super common for these parts to show up on site with issues. Maybe they got warped or twisted during shipping. Sometimes the fabricator just forgets to drill the nail holes you need to attach them to the concrete forms. And every single one of those problems is a delay waiting to happen.
So how do you get through all of this? How do you win the gauntlet? It all boils down to one thing, and one thing only: constant, intense coordination. Communication between the engineers, the fabricators, the rebar guys, the concrete crew. It is absolutely everything.
Which brings us to the final chapter in our hero's journey. After surviving the design phase and the chaos of the job site, it's finally time for it to be, quite literally, set in stone.
You know, the American Society of Concrete Contractors has a quote that just nails it. They say that to make sure these critical parts can actually be installed right, the design and construction team should make coordination their highest priority. It's not just about the steel and concrete, it's about people working together, period.
And then the concrete is finally poured. Our embed is locked in place. Forever. It's now a permanent part of the structure. Its crazy, chaotic journey is over, and it's ready to just quietly and reliably do its vital, unseen job for the entire life of the building.
So, the next time you walk into a building, maybe you'll see it a little differently. Maybe you'll think about more than just the walls and the windows. Maybe you'll think about the thousands of these unseen handshakes, hidden deep inside, all working together to hold it all up.